In this video, we're going to look at transformations of rational functions. Remember that a rational function is a function that is written in the form where you have a polynomial in the numerator and the denominator. The polynomial in the numerator can be a constant polynomial. The polynomial in the denominator must be at least degree 1. The simplest rational function that we've discussed is 1 over x, the inverse function from our basic functions, which has domain all real numbers except 0, range all real numbers except 0, and has asymptotes on the x and y axis. If we look at some basic transformations, these are written in fraction form. So we want to make sure that in order to do the transformation that it's written so that the numerator is a constant. If there's a variable in the numerator, then we want to rewrite the form. So these are both in that form that will allow us to do the transformation right from here. So the numerator is going to be my vertical stretch or shrink. So in this case, I have a vertical stretch by factor 2. And then in the denominator, I have x plus 3, so that's going to be my horizontal shift. Remember, we have to change the sign on that. So we're going to shift 3 units left. On the second example with g of x, we have a negative in the numerator, so that tells us that we have a reflection over the x-axis. The value of my numerator is 1, so there's no stretch or shrink. In the denominator, I have x minus 4, so that's going to be shift 4 units to the right. Remember, we're changing the sign. And then the plus 2 at the end is going to be my vertical shift. So we're going to shift 2 units up. So just a quick review of transformations there. If we have a situation where we have a linear polynomial in the numerator and the denominator, then we can rewrite that into the fraction form so that we can discuss the transformation from there. So in order to do this, first of all, you have to have x in the numerator with a degree of 1 and an x in the denominator with degree of 1. We're going to rewrite this by doing division. So I'm going to actually use synthetic division. So we're going to dividing by x plus 3, so I'm going to make that negative 3 in my synthetic division, and then I have 9 and negative 5. So bring down the 9, 3 times 9 is negative 27, plus the 5 is going to give me negative 32. So now I'm going to rewrite this in that fraction form. Remember, negative 32 is my remainder, so negative 32 over x plus 3, and then my quotient was 9, so I have plus 9. Once I'm in this form, this is similar to the examples we just did. So now I have a negative in the numerator, so that's a reflection over the x-axis. I also have a 32 in the numerator, so that's a vertical stretch by factor 32. Then in my denominator, the x plus 3, that's going to be a shift of 3 units to the left. And then the plus 9 is going to shift up 9, so 9 units up. Looking at 2 more examples here of these. Where you can do polynomial long division if you prefer. I'm going to use synthetic division, so I'm going to rewrite this. So we're going to divide by 2, and my coefficients are going to be 3 and negative 7. So when we bring down the 3, that's going to give me 6 and negative 1. So my remainder is negative 1, so negative 1 over the x minus 2, and then plus our quotient of 3. So it's going to give me a reflection over the x-axis, a shift of 2 units to the right and 3 units up. In our second example, again, I'm going to use synthetic division, so we're going to divide by positive 1. We've got 2 and 4 for our coefficients. Bring down the 2. This is going to give me 6, so 6 is my remainder, so I'm going to write this as 6 over x minus 1, and then plus our quotient of 2. So this gives me a vertical stretch by a factor of 6, and I'm shifting 1 unit to the right and 2 units up.